some serious number science coming at you now. And this is some remarkable discoveries by Thomas Gough and Peter Harris, who have published a new book, A New Dimension to Ancient Measures, based upon this new foot measurement that was discovered a few years ago. And they've applied this research to many remarkable megalithic sites around the country and have been surveying it, surveying many sites. And we're really delighted they've managed to come here, both of them, to share their research with you. They also have a book available, obviously, which you can get after this lecture. They'll be signing books if you want to get a copy. And this is really, really fascinating for megalithomaniacs, because we are of the school of John Michel, also of the school of John Neal or Nosher, and more recently Adam Tetlow and others who've been really pushing forward different ideas beyond the megalithic yard of Alexander Thom to try and understand the whole measurement system of the ancients. And today I think we're going to be in for a treat. So please give a warm welcome to Thomas Gough and first Peter Harris.
It's a real pleasure to be here after nearly 50 years of research. This is the first public meeting that we've had the opportunity to actually explain our ideas. I would like to say, first of all, a big thank you to Hugh for inviting us to speak to the conference. It really is much appreciated. A couple of things I would like to say before we start the shared lecture. I did put some informative flyers out on people's seats. Unfortunately, we're here to do numbers, but we couldn't work out how many seats there were in the town hall. So we've worked on the basis of trying to do 1 per 3 seats. So if you could share it with your neighbours or pass them on. It's a little informative booklet, because Thomas, when he does his part of the lecture, he's drawn the short straw. He will be going into the complexities of the statistics, the metrology, the geometry. So he'll be the one who's got to go through the detail. So we just thought that would be helpful. But it's also got contact details on. So please, if you don't get a chance to speak to us, but you would like to raise any comments, there's an email address there for you to get in touch with us. The final thing that I would like to say is I would like to dedicate what I'm going to say to Margaret Curtis. Margaret sadly passed away a few months ago. She was affectionately known as the Queen of Callanish. She was a close personal friend and collaborator, and I really would urge people, if you get the chance to see any of the booklets or pamphlets that Margaret has written, either in her own capacity or in collaboration with either Gerald Pontin or Ron Curtis, her second husband. But certainly this is a dedication to all the hard work that Margaret did. Okay, in our shared lecture, Thomas and myself are going to discuss the evidence that we produce when writing the book A New Dimension to Ancient Measures. And central to this book is our proposal that a unit of length, which we call the Harris and Stockdale Megalithic Foot, was used to incorporate important astronomical or celestial values into both the design and the building of megalithic structures. So, how did it all get started? I first met Norman Stockdale, who later became my father-in-law, in his hometown of Ramsgate in 1973. In 1975, I took my first teaching post in the same town. Norman was by profession a builder, but he was also an extremely talented engraver and sculptor. But due to serious bouts of illness, Norman, as a young child, spent many months off school. But later in his life, due to his continuing poor health and lack of finance, he had to turn down a number of placements at a number of prestigious art schools where he would have studied engraving and sculpture. And these are 4 of his earlier works. When I first met Norman, he was a member of the local archaeological group, and he'd taken part in an ongoing excavation as a volunteer helper. Norman was fascinated throughout his life with the Egyptian pyramids and had really seriously studied all he could about Egyptology. He had developed both his enthusiasm for archaeology and astronomy, and he'd read a wide-ranging number of books about Stonehenge and Avebury. By now, he'd been introduced to the ideas of Professor Tom, and he'd read all of his books, and he'd also read about many other megalithic sites in both Britain and in Europe. With hindsight, enriched by his wife Jean, herself a celebrated artist and writer, I actually believe that it was his creative and his imaginative life that helped Norman to view the megalithic structures with a fresh eye, particularly in contrast to many traditionally trained archaeologists. Together, we visited Avebury and the surrounding prehistoric remains to be found in Wiltshire, and on our returns to see our families in northern England, we would venture on to Ilkley and Rombold's Moor, observing the stone circles and the cup and ring marked rocks. We both agreed that the megalithic remains we encountered offered far more than just being magnificent pieces of art and engineering. We felt that they provided a connection between humankind and the heavens, creating a sacred landscape. Norman, as a professional builder, was convinced that measurements had been employed in both the design and the building of the megalithic sites. And we both felt that many of the megalithic structures across Britain, Ireland and Brittany had common features. And so we reflected on whether the universal features of life and death and rebirth were somehow encapsulated in the megalithic architecture, possibly in a symbolic way, by using astronomical and universal units of time featuring the sun and the moon. Many months of background research, including discussions with local astronomers and visits to the University of Kent at Canterbury, helped us crystallise our thoughts, because we both agreed that important astronomical values, including, say, the calendar year of 365 and a quarter days, the eclipse year of 346.62 days, and the lunar cycle of 18.61 years might have been used by the megalithic designers. Now, by this time, Norman was corresponding with both Alexander Thom and his son Archie, and he was also seeking clarification of measurements from other leading archaeologists such as Aubrey Burl and Richard Atkinson. But we felt that rather than the 33-inch long megalithic yard proposed by Professor Thom, we felt it was more feasible to have a more workmanlike measure at between 12 or 15 inches. And we thought that we then could have smaller divisions for use in the cup and ring markings. It's been suggested that the near rectangle that's formed by the station stones at Stonehenge consisted of a pair of Pythagorean triangles with sides having the ratio of 5 to 12 to 13. And it was also speculated that the 18.6-year lunar cycle was very, very important in the early stages of the Stonehenge monument. And we wondered if the value of 18.6 might somehow have been incorporated into the length of the rectangle. As the slide illustrates, we took the long rectangular length of approximately 263 feet, and we divided it by 18.6 times 12. And the answer we found was approximately 14.14 inches. We also took an average of the short rectangular sides at about 110 feet, and we divided that by 18.6 times 5. And the answer was again approximately 14.2 inches. Similarly, with the diagonal, we divided its 285 feet length by 18.6 times 13, and we got the answer of 14.14 inches, a total average of 14.15 inches. So, out of curiosity, we then looked at what we considered to be the earliest beginnings of Stonehenge, the bank and the ditch, whereby using the 14.15 inch measurement which we'd found at the station stones, once again the 18.6 value appeared to be present. The ditch was equal to approximately 18.6 times 50, and the bank's total perimeter being double that at 18.6 times 100. So, feeling that this was more than coincidence, we used the 14.15 inches really as just a mathematical starting point. But we shifted our focus to as many stone circle measurements that we could get, primarily using the dimensions provided by Professor Tom. However, we also looked at the measurements provided by other archaeological surveyors, as well as using our own survey results. Norma and myself had already studied and surveyed the data for 3 of the stone circles on Ilkley Moor, and because of the many springs and the streams on the moor, we instinctively felt that the carved rock known as the swastika stone would be predominantly lunar based, especially with its high viewpoint over the River Wharfe. Because of its small linear design, in contrast to more of the more complex rock carvings on the moor, the swastika stone really posed us a very stimulating challenge to our speculations as regards this proposed 14.15 inch unit of length, and in particular to the possible smaller division of that measurement. We also chose the swastika stone for very practical reasons, because the design was very small and it only had 10 cups. Having made a rubbing of the swastika stone, there really did follow a long period of trial and error for varying uniform or unifying divisions of the 14.15 inch value. We were aware of the Egyptian cubit and the royal cubit being divided into 28 parts, but we eventually agreed on 56 equal divisions. And what finally convinced us that 56 divisions of just over 1/4 of an inch was in use was when we practically used this measurement, later named for convenience the Harrison-Stockdale Megalithic inch, because we both felt that it produced astronomical data that was way beyond the realms of coincidence or chance. As can be seen in the slide, we measured the swastika stone with great care. We used nails closely down the center line of the groove, and we also used non-stretched cord. And using these 56 divisions of the 14.15 inch unit, it gave us a length very close to a possible value of 346.6, which is the eclipse year. Secondly, we considered the diamond shapes, and unexpectedly, they provided us values for the 27.55 anomalistic month. The small inner diamond, as you can see, gave values of 27.55 times 3. The outside diamond gave a value of 27.55 times 6. And astoundingly, when you extended it to the 10th cup hole, it gave the value of 27.55 times 10. Now finally, we considered the triangle shapes, which to our real surprise provided values which appeared to be for the 29.53 day synodic month. The first triangle value was 29.53 times 13.5, but the sum of all the values equaled 29.53 times 30. And I should add at this moment, not jumping into Thomas's talk, that these measurements have been reassessed for our new book to an error of 0.01%. So after 2 or 3 years working on the research data that Norman and myself had amassed, we both felt increasingly confident that there did appear to be a mathematical case for the measure of approximately 14.15 inches, and that it was divided into 56 equal parts. But in an attempt to further test our hypothesis, we widened our research data to now include stone rows, the perimeters of flattened circles, rock carvings, and the megalithic structures from both the UK and Ireland, plus northern France and Scandinavia. Based on the multitude of data that we'd collected over nearly 40 years, both Norman and myself had now redefined the measurement to 14.142 inches. And we'd been further convinced of the validity of this measure being 14.142 inches when we discovered in the mid-1990s that 10 times the square root of 2 inches was a very ancient measure, and that in early Babylon, the square root of 2 had been known accurately to 6 decimal points, as demonstrated in the slide. But unfortunately, in 2008, Norman Stockdale died, and effectively our private correspondence and collaboration, nobody else had been involved. Basically, our measurements and our speculations had come to an end. A few years later, I attended a meeting in Liverpool where the guest speaker was Dr. John Hill, an experimental archaeologist and a lecturer at Liverpool University. And we discussed megalithic architecture and measurement, and he invited me to speak with him later. And this resulted in me making contact with John Billingsley, who is the editor of the Northern Earth Journal. Both of these men were really extremely supportive and helpful, and it led in 2015 to the publication of my first book, Astronomy and Measurement in Megalithic Architecture. Now, as a result of the success of this book and a very positive review on the Megalithic Portal website, the editor of the portal, Andy Burnham, created in 2016 a forum thread specifically for the Harris and Stockdale Megalithic Foot. Now, to date, this has had over 82,000 visits and over 1,500 comments have been left. Not, I should say, all congratulatory or pleasant, but what it did do was it raised with me many questions from a much wider range of backgrounds and disciplines that I have to admit I was unused to. And it became very apparent that my initial book, which is still for sale outside, And the work that I'd been doing with Norman, it had to be updated. Not only had it to answer the new questions, but it also had to subject our data and research to thorough and independent assessment, because I wanted Norman and myself to be vindicated, if possible, both objectively and impartially. And I wanted to be used the most up-to-date computer statistical programs. And even for myself, just for my own peace of mind, I needed to dispel any doubts that I had concerning mathematical or just numerical coincidence. So in 1916, I came into contact with Dr. Thomas Gough, and this led us to collaborate and to co-author the book entitled A New Dimension to Ancient Measures. And I will let Thomas, hiding in the wings, to continue. Thank you very much.
Thank you. Good afternoon. When Peter and I wrote this book, our initial purpose was to show that the HSMF existed in ancient times and was used in Neolithic Britain. We soon realized that the implications of the use of that use demonstrated a much greater level of knowledge and ability than is currently accepted. I hope to show this. Peter has indicated that the HSMF is 14.142 inches, i.e. 10√2. This is the diagonal of a 10-inch square. So what is the evidence of the inch in prehistory? The width of the Parthenon platform was measured with great care by Penrose in 1888. He found a width of 101.34 feet. 101.25 feet is the Greek measurement. Does anybody, multiplied by 60, which was used in prehistory, sexagesimal, you get those values, just over 6,000 feet. Does anybody recognize that value? Anybody? Any offers? It's a nautical mile. It is a nautical mile. It is 1 minute of latitude. And so the result is that we conclude that the Greek foot has a geodetic origin. In other words, it is based on the dimensions of the Earth. So how big is a minute of latitude? Well, there we have Glastonbury, minute of latitude marked. Now, we need to trim that down a bit. So what is a second? Well, that is 10 seconds of arc. And that is 1 second of arc, the width of the Parthenon platform. There is an ancient small unit of length called the digit. In 1953, Berryman wrote a useful book on ancient measures, volumes and weights. He discusses the digit. The Roman foot was rated 16 digits, which makes the length of this digit 1/54th of a meter. There are 100,000 of them in a terrestrial minute of arc, measuring 6,000 Greek feet, and it is convenient to call this distance a geodetic mile. So, what is the length of the digit? You have the values there calculated from 1/54th of a meter or from 1/16th of the Roman foot. It's a little less than an inch. Berryman gives several ancient unit lengths. These ones show are either a multiple of the digit or are related to such a value in a simple way. The Sumerian cubit is marked. This is 19.8 inches. It is 14√2. i.e. it is the diagonal of a 14-inch square, as the HSMF is the diagonal of a 10-inch square. The pole of 16.5 feet is an old measurement, but still used by surveyors. The pole is 10 times the Sumerian cubit, or 14 times the HSMF. We move on to the use of the HSMF. Most of the following concerns the rings surveyed by Alexander Thom and as published in the book British Archaeological Reports, BAR 81, 1984. Aubrey Burrell added comments. Testing the dimensions of megalithic remains for the use of the HSMF. Only structures which were believed to have been accurately measured were used for the analysis of the HSMF. Alexander Thom measured several hundred stone rings, all with great care. He listed the diameters and perimeters of 62 true rings, all of which we used. The dimensions were converted from the original to the HSMF. That is the left-hand bold column. The smaller celestial values were 18.61, 27.55, and 29.43 were divided into the value, but the larger numbers, 346.62 and 365.25, were divided by the values. This, in most cases, gave the results which were greater than unity, thereby simplifying analysis. Peter has mentioned the numbers here. 18.61 years is the standstill period of the moon. 27.55 the anomalistic month, and I will have much more to say about that later. 29.53 the synodic month. 346.62 the eclipse year. Here there is a hit for 27.55. That's the right-hand bold. The eclipse year is eclipse period is 1/2 of the eclipse year. This is part of the page of Excel tables made for all rings. Unit lengths other than the HSMF were tested. The colors indicate the percentage error from the ideal value. Red bold, 0 to 0.2%. Red not bold, 0.2 to 0.5%. Only hits up to 0.8% error were considered. Chance hits will always occur. At this early stage, hits using simple fractions were accepted. The results were plotted on maps. This is the one for England and Wales. There is a key at upper left. This is rather crowded, and so I have extracted this region. The blue dots are the anomalistic month, the red dots the eclipse year. These sites are all very familiar. We have the initial evidence that both of these celestial time periods were known in prehistory. I show again an early Excel table which was made by hand. Each of the 5 celestial value columns are easily made. The problem is visually analyzing the results. Each of the hundreds of values has to be assessed for the error 0.2, 0.2 to 0.5, etc., and then total to each column. This is very time-consuming and mistakes easily made. This was not satisfactory, except for the initial work. I therefore approached Victor Rees. I had met him at a number of SEAC conferences. His presentations were on computer-based analyses of varying nature. Mine at that time continuing the work of Alexander Thom on lunar and solar alignments. SEAC stands for Astronomy in Culture in French. It is a European group meeting each year to present papers. I sent the required data for the rings to him. These included the dimensions of the 62 true stone rings, as surveyed by Professor Tom, and the 5 key celestial time periods. He produced a series of increasingly detailed Excel tables. The Excel tables enabled any unit of length to be tested at the click of a button, not only the HSMF. The output of each unit of length consisted of a concise table. This is the example for the HSMF. Noting the value of the HSMF as 1.1785 feet, my brother, J.W. Gough, ran a statistical analysis using Z-score. This compared the HSMF output with that of 50 random numbers in the range 0.8 to 2. These were generated by the Microsoft Excel RAND function. The results show that the HSMF was very strongly associated with the anomalistic month, to a lesser degree to the eclipse year. None of the other 3 celestial values showed any significant association. The analysis confirms that the HSMF has a prehistoric origin. The original name is lost to us, but from now on, when we refer to the HSMF, we must think of the original prehistoric unit of length. In order to check these results, 3 independent statisticians were consulted. Each was sent the necessary data, but with no indication of the topic. They all validated the results. The results and details of the methods used are in the book, A New Dimension to Ancient Measures. It includes all of the data used so that anyone wishing to check the analysis can do so. I digress here to introduce some important ideas about the Neolithic. The analysis of true rings has shown that the HSMF and the periods of the anomalistic moon and eclipses were known. They were used in the construction of many megalithic structures. An example here is the well-known stone circle rollright. The dimensions are shown. When the perimeter is converted to feet, it is 276.2. This is close to 10 times 27.55. The construction of a ring with a particular perimeter demonstrates skill and knowledge. The anomalistic moon. The apparent size of the moon varies because it is in a slightly elliptical orbit. This variation would be difficult to observe, but records show that the Babylonians knew of it by about 600 BC. We now find that it was known in prehistory. The moon has a very complex orbit, and the period of the anomalistic moon is very variable. The mean could only be found by recording the number of days taken for 100 or more cycles and then finding the average. Eclipses would require careful, long-term observation to determine the period of 173.3 days. In a year, there can be 3 eclipses or none at all. All of the above implies a much greater level of ability and organization in the Neolithic than is currently accepted. May I suggest a learned group, perhaps of astronomer priests, as termed by Ewan Mackay. We now come to discuss some unit lengths. Root 2 with the inch is the basis of many unit lengths. The links between them are straightforward using integers and root 3. Note that 4.714, it will occur again. The relationship between the HSMF and the perch or the rod has been mentioned previously. This is not really very satisfactory, trying to determine new lengths from that one, from an older one. Using triangles is much easier. These triangles have root 2 and root 3 in their proportions. The second triangle, scaled up, gives 4 times the right-hand triangle. The HSMF is easily converted to the Thom's megalithic yard. It is not known how these lengths, once identified, were stored and transferred. Rods are likely to be used locally, but probably not over large distances and long periods of time. Pendulums of the length required to give a number of swings in a certain period of time could work, the time being the passage of the sun or star over a 1 degree. It seems likely that the origin of prehistoric unit lengths was mainly during the early civilizations in Mesopotamia, perhaps around 5,000 or 6,000 years BC, maybe earlier, and these were then transmitted to distant lands. The lower left is a drawing of a small part of the foundations of a temple built there about 5,000 BC. A grid of 72 centimeter squares fits over the foundation bricks. 2 HSMF is 71.86 centimeters. It is suggested that the HSMF was used. A bath in northwest India is built of special bricks. The 2 long sides are 471 and 472 inches. Mean length 471.5 inches. The number 4.714 is easily obtained from the HSMF, as indicated before, and so this suggests its use. If the bath's mean length of 471.5 inches is not related to the HSMF, then this is a remarkable coincidence. The HSMF also was known in China. It was known as the Hung Chai, or official chai. The chai of 7.07 inches was used by the people. Confucius was 9.6 chai, or 5 feet 8 inches, and was considered to be very tall. The length also traveled west. The ancient foot of 1.1 foot was used by the North Germanic tribes and brought to England when the Romans left. The Saxon foot was used until the medieval period, when it was changed to the foot of 12 inches, which therefore has a prehistoric origin. Thom's megalithic yard and the HSMF are both found in Karnak. Thom's megalithic yard was used, but it seems to have been found only in limited structures. Karnak has been mentioned. It was used in the construction of some egg-shaped rings. This is Balnuran of Clava, a complex near Inverness. 2 back-to-back Pythagorean triangles are used. The radii are centered as indicated. Note this value, 125 megalithic yards. It will occur again in the discussion of the eclipse year. Some thoughts. There is ancient evidence for the HSMF, the Sumerian foot, and the Sumerian cubit. These 2 were both derived from the Shusi of 0.66 inches, as were other lengths. So the Thom megalithic yard, was it derived from the mid-digit or the Shusi? It doesn't in fact fit. It's not too bad for one of them, but it's not close enough. It's suggested that this is the derivation of the megalithic yard from the HSMF. We will return to this later. The unit of 4.714 feet and 4 has been mentioned before. It's also used as 4.71 inches, 1/3 of the HSMF. Alexander Thom's son Archie investigated stone circles in Scandinavia in 1980. He measured the ellipse, which is found based on triangle 3, 4, 5. He expressed surprise when he found that the unit length used was close to 4.71 feet. The small bush barrow lozenge of very thin gold was found on a skeleton in 1808. The barrow was near Stonehenge. Other valuable items were found. The dimensions are very close to those shown. Now, Stonehenge. There's a pair of near 5, 12, 13 Pythagorean triangles within the station stone rectangle. When Peter and Norman Stockdale investigated the dimensions, they were not concerned with precision. It was simply a case of testing for the possible use of celestial values, and they found that using 18.6 and whole number lengths was, for each of the three sides, gave a common multiple of about 14.15, as Peter talked about earlier. This was their initial breakthrough. Here we use the precise measurements of Norman Atkinson. There are some surprising results. Let me talk you through that one. The short sides are really very different in length. One is 107 feet about, and the other 112. When you take the mean of those, then you obtain a length of 109 almost 7 feet. 5 times 18.61 in HSMF converted to feet is almost the same value. The error is only 0.03%. When you carry out the same calculation for the long sides, you find a very small error. And for the diagonals, similarly, a very small error. There can be little doubt that these were planned. The Stonehenge sarsen circle. The diameter is accepted as 97.4 feet. Converted to HSMF, this is exactly 3 times 27.55. The lintels are widely given as 3.5 by 10.5 feet. These are very close to 3 and 9 HSMF. The outer diameter is therefore 104.4 feet. And converted to HSMF, this is very close to 3 times 29.53. The inner and outer circumferences are both related to the eclipse year. The explanation follows. The Tom Megalithic Yard, the HSMF, and the eclipse year. We noted earlier the relationship between the HSMF and the Alexander Megalithic Yard. The eclipse year, 346.62 days, and with 150 megalithic yards converted to the HSMF, that is almost exactly the same value. This is a mathematical relation which stands even if the Tom Megalithic Yard is not derived from the HSMF. There are a significant number of true circles where either the diameter or the perimeter are simple ratios of 346.62. 2 examples are given. Eclipse multiples in true stone circles. I will let you look at that table for a moment. Note the number of rings at 288 HSMF, which is close to 125 megalithic yards. Anything missing from that list? Nobody see anything missing? What about the Stonehenge rings? The left-hand side there is the ratio, or the value that needs to be divided into 346.62 in order to obtain the right-hand number shown. And I think you can see what it is. When you have ratio 2, then instead of having the megalithic year, it comes down to the period, 173, and so on. The inner circle is accurate to within 6 inches in 300 feet. The results for Stonehenge, arguably the most important Neolithic monument, confirm both the knowledge and use of 27.55 and 346.62 together with the HSMF, and that they are key elements in the construction of Stonehenge. Eclipse values using non-circular rings. We discussed this egg-shaped ring earlier. I said then that we return to the perimeter. I expect you have by now guessed why. The perimeter is close to 346.62 divided by 1.2. Achieving the required values for non-circular rings would be difficult. There are other examples. Castle Rig in Cumbria, Mitchell's Fold in Shropshire, and Batalic in Cornwall. The Excel tables are in the book. These quotations summarize the situation before the rediscovery of the length, now called the HSMF. And more recently by Robin Heath. While there is doubtless much yet to be found, in some respects this has now changed as a result of the work of Norman Stockdale and Peter Harris, aided by the very precise measurements of Alexander Thom. We move on briefly to precise lunar alignments and the importance of knowledge of the period of the anomalistic moon. Alexander Thom, an image of him at Stonehenge in 1973, age 79. The writing at the bottom is rather small, and so I have given part of it. Lunar alignments, lunar eclipses, and the significance of the knowledge of the period of the anomalistic moon. A general understanding of what follows is useful. The moon's orbit round the Earth is tilted at about 5 degrees. The nodes, N1 and N2, precess slowly round, taking 18.6 years. Here the moon is shown at the maximum declination. A schematic diagram of the declinations of Sun and Moon over 18.6 years. The moon's declination slowly increases for 9 years to a maximum, a standstill, and then decreases. The major stands still in the north. The dots mark the moon centers. Declinations are for 1750 BC. There is a formula which Thom used in order to determine that in one of his books. Most of the moon's orbit is inclined, because the moon's orbit is inclined at about 5 degrees, as it goes round it experiences a slightly varying attraction from the sun. Its maximum declination therefore varies slightly by about plus or minus 9 minutes of arc. That is not very much, and that is what it is like in real time. Only the points where the red dots are when the moon is stationary, and those are the only points which one can measure with precision. This description helps to understand the moon's movement. There is no reason to suppose that these details were known to those setting up the alignments. In order to save time, I am not giving details of how the declinations are determined. It's a little complex and is fully explained in my website, lunarsitesscotland.net. Lunar alignments tend to be well marked. The observing position is critical. Tom assessed sites over much of Scotland and in Wales. He found only 2 in Argyll and 1 on the island of Islay. The present investigation found many more sites in the region, but few elsewhere. Some lunar alignments. Netherlargy, Kilmartin in Argyll. This was a site that Tom visited many times. It was here that he first identified a lunar alignment, completely unexpected at the time. The notch is small but distinct. The first quarter moon near March equinox. The path of the moon is at right angles to the terminator, so that both limbs are lit. Note that the declination is very close to the theoretical value. The moon at this time is always at first quarter. The site at Ford, a few miles away. A single stone with a flat left side. The foresight is a small rocky peak 3 kilometers distant. Note that the foresight is unambiguous. The rising third quarter moon at the autumn equinox. Using the lower limb ensures maximum visibility. Again, note the small declination difference. The third and final example in the same region is a full moon, Salachri, a 3-stone row with 2 fallen, situated where there is higher ground to east and west. Any alignment can only be in the south. The rocky ridge is indicated. The upper limb of the full moon, with wobble to the north, would twinkle down the rocky ridge. The understanding of the moon's movements by those who set up the alignments would have been based on generations of work. There had to be a reason. The information obtained would have enabled eclipse prediction, although we have no proof that this was done. In China, 5,000 years ago, the emperors employed astrologers to study the heavens. Eclipses were considered to be a danger to the emperor, and so the task of 2 of the astrologers was to predict eclipses. At the appointed time, the emperor would assemble his warriors to bang drums and fire arrows as the eclipse began. Why? It was to frighten away the dragon, which was believed to be trying to devour the moon. So what happened to the astrologers if they failed? There is one reliable record. If they didn't predict the eclipses, they were beheaded. Final slides. In the northern region, there are 7 precise alignments in Argyll. These differences from the theoretical value are shown. All sites had at least 1 return visit to check the result. Many had 3 or 4 visits. The mean value is shown. The precise alignments in the south. Precise alignments in the south. The anomalistic moon. The lunar alignments. The horizontal parallax of the moon varies from 54 to 61.4 minutes. Variation is plus or minus 3 minutes of arc. The mean declination range of the 11 lunar sites in the region assessed is 1 minute of arc. This low value was made possible by prehistoric knowledge of the moon's variation in size, which could have been allowed for when putting up the sites. The precision of the lunar sites by Tom is similar, but since there was no evidence that the variation of the apparent size of the anomalistic moon was known in prehistory, he was unable to explain his results. This led to his results being considered to be due to chance or to unintended bias. However, Tom's work is now vindicated. The prehistoric knowledge of the moon's variation in size would have made accurate sighting of the back sites possible. So what conclusions can we reach? The Z-score analysis effectively proves that the values 3, 27.55 and 346.62 were intentionally built into the design of many stone circles. This shows knowledge of the mean periods of the anomalistic moon and the eclipse year, both of which would have required long-term observation and record keeping. The accurate construction of the rings would have required planning, calculation, and careful measurement. Without the discovery of the HSMF and the knowledge of how it was used, these conclusions would not have been possible. All of this indicates a much greater level of knowledge and ability than is currently accepted, and ought to revolutionize our understanding of the Neolithic. Thank you.